Good morning to all of you. Welcome you guys. Welcome you all. So I think we are live. So सबसे पहले बोलिए ना, is my audio videos clear to everybody? Yes, is the audio videos clear to everybody? Tell me. Yes, first of all, do comment करके बोलिए ना. Is the audio videos clear to everybody? Yes. And all of you do like the session and share to all your friends. All of you like the session. First of all, everybody. All of you do like the session. Right. Yeah. So, chalo. So, we are going to discuss about the subject that is electromagnetic theory. So, this is one of the very, very important subject. So, here in this electromagnetic theory, what we are going to discuss here, what we are going to handle. Let's have a discussion about this electromagnetic theory. This electromagnetic theory, this is what you tell me now. This is a branch of electrical engineering which deals about the interaction or the interplay mechanism between electric field and the magnetic field. Here we are going to discuss about the electric fields and we'll talk about the magnetic fields. We are going to discuss about what is meant by electric field, what is meant by electric field and what is a magnetic field, and how this electric field will affects the magnetic fields, and how this magnetic field will affects the electric field, right? The interaction or the interplay mechanism, between interaction or the interplay mechanism between electric and the magnetic fields is called as a electromagnetic fields. Okay, right. Find the interaction or the interplay mechanism between electric and magnetic fields called as a electromagnetic fields. Now what is the thing we are going to discuss now here? Here we are going to discuss about one fundamental particle, that is a charge. The fundamental particle we are going to discuss about here is the charge. And the charge can produce electric fields. The charge can produce electric fields, and the same charge can also produce magnetic fields. Can also produce magnetic fields. Then the same charge can also produce electromagnetic fields. Okay. The charge is a fundamental particle. The charge can produce electric fields, magnetic fields. It can also produce electromagnetic fields. Now let us see when the charge will produce electric field, when it will produce magnetic field, when it will produce electromagnetic fields. Charge means what? Tell me now. Basically, charge is a particle. Charge is a one particle. In general, how the particles are? Some particles are stationary. Some particles may be under motion. Some particles are stationary. Some particles may be under motion. Let us consider my charged particle is at rest. If the charged particle is at rest, then what will happen? What will happen? You tell me now here. So here in this case, what will happen now? Charge is at rest. So consider we have taken one charged particle Q I have taken and assume that this Q is at rest at this location fixed here. Now you see this thing, what happens now? If I bring one more charge nearby it now, then what happens now? The other charge will experience a certain effect of the charge, isn't it? So this other charge will experience certain force. It may be attraction, may be repulsion. That depends upon the polarity of the charges. Now if we place the charge here, we have the charges will experience the effect of the charge now. So that means what I can say now here, the charge can able to create certain region all around the charge. So all this region is controlled by the charge, isn't it? If we have taken some random point we have taken in this region, we have certain effect of the charge at this location. So the effect of the charge at this particular point is called it as a electric field. The effect of the charge at certain point is called as a electric field. And how this electric field now here, if we have taken the point here, we have some effect, here we have some other, here we have some other, here we have some other now. That means the effect of the charge will varies with the distance now. I can say the effect of the charge, that is nothing but electric field, which changes with the space. That means we can say depends upon x comma y comma z, I can say. It depends upon x comma y comma z. And so this effect depends upon space. Will the effect depends upon time? No. Why? Because how the charge, you tell me now? The charge is at rest. If the charge is at rest, the effect of the charge remains constant. It is independent of time. Now you see, the effect of the charge will depends upon space and that is independent of time. Since it is independent of time, this we are calling it as a static electric field. This we are calling it as what? Tell me now. Static electric field. What is the static means? What? Independent of time. The study of the static electric fields is called as a electrostatics. The study of the static electric fields is called as what? Tell me now. Electrostatics. Yeah, tell me this thing here. If we have a charged particle, the charge will produce some field. That field, how the field is a depends upon only on space, independent of time. Since it is independent of time, we are calling it as a static electric field. The study of the static electric fields is called as what type, electrostatics. Okay. Now, now. So we have taken now the charges at rest. Now let us say here, let us consider other case now. Charges are moving. And this moving, how they are moving, you tell me now here. Moving with uniform velocity. Charges are moving with uniform velocity. And so let us consider we have, let us say this is my conductor, some conductor. In this one, let us say the charges are flowing like this. As we know, whenever the charges are flowing through a conductor, we have a current through the conductor now. Whenever there is a flow of current through a conductor and we have a magnetic field around the conductor, we have a magnetic field around the conductor. We know this thing now. Tell me, all of you. We have a magnetic field around the conductor, isn't it? So now look at now here charges are there, charges are flowing. So as we know here, so here whenever the charges are there, flow of charges will cause us what, tell me? Flow of charges. Flow of charges will cause us what, you tell me now here? Because of flow of charge, we have a flow of current. Flow of current. Flow of charges will cause us flow of current. Because of this current, what we have, tell me? We have a magnetic field. Because of this current, we have what, tell me? Magnetic field. All of you tell me this thing. Flow of charges will cause us the current. Because of the current, we have a magnetic field, right? Now you tell me now here how the charges are flowing here. Here charges are flowing uniformly. So that means uniform flow of charges. Uniform flow of charges will cause us what, to tell me? Because of uniform flow of charges, we have a current. How we have a current is a, we can say uniform current. What I can say now, this is a uniform current. What is meant by uniform current is a uniform current. So that means constant current. What we'll call this constant current is a, which we can say now DC na, independent of time. And because of this uniform current, then what we have, tell me? We have a magnetic field. So because of the current, we have a magnetic field. Because of uniform current, we have a magnetic field. How the magnetic field is a uniform magnetic field, constant magnetic field, which is independent of time now. Since it is independent of time, so I can call this magnetic field is called as what, tell me? That is called as a static magnetic field, and we'll call this as what, tell me now? Static magnetic field. Static means what, tell me now? Depends upon only on the space only, independent of time. So the study of the static magnetic fields, which we can call it as what, tell me now? Magnetostatics. So this is called it as what, you tell me now? Study of this static magnetic fields is called as a magnetostatics. Okay, right. Then ये पॉइंट सभी को क्लियर हो गया ना? दिस इज what is this magnetic field. Here we have taken how the charges are moving. You tell me now. Charges are moving with uniform velocity, constant velocity. Constant velocity means what current is in? What is this current is called as a DC current, isn't it? So this constant current, which is called it as a DC current, right? So because of this DC current, we have a magnetic field. So this value constant. Clear na? Right. Now let's see this thing here. Now let's see what is the other possible case now here. Charges are with uniform velocity. Now what is the other possible case now here? Let us say charges are moving with a non-uniform velocity. If the charges are with a non-uniform velocity, now see what will happen. And third case, let us consider here charges. Charges are moving. Charges are moving with what you tell me now here, non-uniform velocity. With non-uniform velocity. Now non-uniform velocity means time varying velocity na? Right. Now here you see this thing here. Because of these charges, if we have a charge is there, so we have the electric field, isn't it? If the charge change with the time, then what happens now? If the charge is a function of time, because of that, we have the electric field. And how this electric field, you tell me now here. Electric field which depends upon x comma y comma z. So the charge is also changing. So electric field also change now, tell me. All of you. Charges are moving with non-uniform velocity. The charge changes. Electric field is also changed now with the time. Now, if the charge varies, what about the current? If the charge varies, what about the current? Current also change na? Current change with the time. If the current change with the time, then we have a magnetic field. How about the magnetic field is now? Magnetic field also change with the time. Magnetic field is also change with the time. Everybody. So in this case, what happens? You tell me now here. Electric and magnetic fields are depending on space as well as time also. Depending on what I mean space as well as time also. So in this case, earlier the electric magnetic field depends upon only on the space only, independent of time. That's why we call them as a static field, static electric field, static magnetic field. Now here what I can call them, you tell me now. Now these are depending on time now. That's why these are called it as a dynamic fields. What we can call them as a, tell me now, these are called as a dynamic fields. Dynamic fields. So in this case, so here in this case, electric field depending on magnetic field, and this magnetic field depending on the electric field. In this case, electric and magnetic fields are interdependent. That's why combiningly this we used to call them as what, tell me now? Electromagnetic fields. We are calling them as what, tell me now? Electromagnetic fields. Is it fine to all of you? Tell me. When the charges are moving with a non-uniform velocity, electric and magnetic field depending on both space and time. So that's why these are called as a dynamic fields. In this case, electric field depending on the magnetic field depending on electric field. So these are called as electromagnetic field. Okay. Right. Yes, all of you do like the session, everybody. All of you do like the session immediately. Clear now, yahan tak? Now you tell me now here. So you tell me now here. Here, first case, when you are coming to first case, here we have taken the charge now. Here we are talking about only electric field only. What about the magnetic field? You tell me now. अगर magnetic field होगा कि नहीं? Do we have magnetic field or not here? We have. Do we have a magnetic fields or not here? Do we have a magnetic field in this case? Now case 1 when the charges are at rest. हुआ कि नहीं? So magnetic fields are caused by what? Tell me now here. Current. Current. Because of the current we have a magnetic field, isn't it? Here the charges are there, charges are at rest. Do we have any current here? No current. No current means no magnetic field. So in this case, what we have, tell me, we have only electric fields only. In this case, we have only electric fields only. Okay? When the charges are at rest, we have only electric fields only. Now when you're coming to here, now you tell me now. When the charges are moving with uniform velocity, in this case, we have talking about the magnetic fields we are talking. What about the electric field? Magnetic electric field hoga ki nahi? Do we have an electric field or not in this case? So we are talking about only magnetic fields we are talking now. What about the electric field I am asking? Whether we have electric fields present or not, no electric fields. Yes, do you have electric field in this case? What causes electric field? Charge. In this case, do you have charges are there or not? Charges are there, isn't it? Charges are there, charges are moving now. If the charge is present, we have electric field is there, isn't it? So that means what we can say now, in this case, we have electric fields also. When the charges are moving with uniform velocity, in addition to magnetic field, electric field is also present. But electric and magnetic fields are independent of each other. But electric and magnetic fields, how these two are independent of each other. Understand what I am saying? But electric and magnetic fields are independent of each other. Clear? But here in this case, where the charges are with non-uniform velocity, electric field is there, magnetic field is there, and both are interrelated. Electric field connected with the magnetic field connected with the electric field. That's why these are called as a dynamic fields. Right. Now you can have a look at now here. When the charges are moving with uniform velocity, both electric and magnetic fields will exist. But what happens now here? Electric and magnetic fields are independent of each other. All of you? Done. Done. Right. Now you can have a look at now. So let's talk about the general analysis. Now here I think all of you know about the basic law of universe. What the basic law of universe is a? That is a law of conservation of energy. Law of conservation of energy. So that is energy can neither be created nor be destroyed, but we can transform it from one form to another form. Isn't it? So basically energy, as we know, energy which is available in the form of a packets, and the energy will travel from one point to other point in the form of a waves. So that means what we can say now, energy is a dual nature. What is the nature of energy? It has a particle in nature. Energy is in a particle in nature, as well as energy which is in wave nature also. Energy will propagate from one point to other point in the form of a waves. Particle in nature and wave nature, isn't it? Now, here this particle in nature. So if we're talking about this particle, some particles, some particles will have a mass and some particle will have a charge. Some particles will have a mass and some particles will have a charge. Right. Now, this particle, some particles will have a massed particle and some particles will have a charge. Now, if we talk about the massed particle, if the massed particle is at rest, let us consider. Particles means it may be at rest or it may be under motion. If the particles are at rest, it has an energy. What type of energy it will contain? And when the particles are motion, it has another type of energy. What type of energy it will contain? When the massed particles are at rest, when the massed particles are at rest, it has the energy. That energy we are calling it as what element of potential energy. When the particles are under motion, when the particles are moving, it has some energy. What type of energy we'll call now? If the particles are moving, we can call that energy as a kinetic energy. So exactly similar to that. So here, so like we have for the analysis of a massed particle, we have defined the two energies for the massed particle. When the particle is at rest, we call that energy as a potential energy. When they are moving, we call that energy as a kinetic energy, right? Exactly similar to that, for the analysis of a charged particle, for the analysis of a charged particle, we have defined the two energies for the charged particle also. When the charged particle is at rest, when the charged particle is at rest, it has some energy. When the charged particle is at rest, it has some energy. And that energy which we are naming it as a electric field, that we are calling it as, what you tell me now, electric field. And this particle which are moving, when these are moving and we have the energy, that energy we are naming it as a magnetic field. All of you, this energy we are named it as a magnetic field. Now you can see now here. So the particle, if the particles will have a mass and charge. The massed particle, when it is at rest, we have defined that energy as a potential energy. When they are moving, that energy we named as a kinetic energy. Exactly similar to that, when the charged particles are moving, that energy we call it as an electric field. When they are moving, that energy we named as a magnetic field. Is this point clear to all of you? These things are clear to everybody. अगर clear हुआ तो सभी ने आपका अगर हाथ दो. If this point is clear, so you can show here. सभी ने अपना आपका हाथ दो. Yes, is this point clear? All of you do like the session, everybody. Do like the session, all of you. Clear ना सभी को बोल. Yes, so here मजे आए कि नहीं आपको सभी को बोल. Right. Yeah, you tell me now. Coming to the wave analysis now here. Yeah, you tell me now here. If the waves. Now, generally, we should talk about two types of waves. One, we used to call it as a VI waves. VI waves. VI waves means what I mean now, voltage and current waves. VI waves. The other one is electromagnetic waves. EM waves. EM waves. VI waves. The other one is electromagnetic waves. Now, VI waves means what? Tell me now, voltage and current waves. So, for the propagation of generally VI waves are very low frequency waves. The frequency of the VI waves, voltage and current, if we have seen, that is a 50 Hz frequency. 50 Hz frequency. And for the propagation of voltage and current, sigma value tending to infinity, conductivity must be very high now. But whereas electromagnetic waves frequency is very high, very high frequency, and then conductivity is which is almost equal to zero. Okay, so that means VI waves, voltage and current waves. In our voltage and current waves for the propagation, how much the sigma value? Sigma value, how much? Infinity. But frequency is a very small, you see. But electromagnetic wave, example of electromagnetic wave, light na, sunlight is an electromagnetic wave. So what is the medium between the sun to earth? There is no medium at all, isn't it? So there is no medium means no sigma na. Sigma value 0, but the frequency of electromagnetic waves is very high. Okay, so that means what I can say now, electromagnetic waves are high frequency waves and those will propagate to sigma value 0. But VI waves are low frequency waves and those will propagate only through a conductors only. Okay, and so, and to convert these electromagnetic waves to VI waves, we use one special device we use. Like your mobile phone was, so here headset will connect now. What the headset will contain, you tell me now, it will contain some inbuilt antenna. So it will contain antenna. So here basically the electromagnetic waves are high frequency waves. These high frequency waves we have to convert into low frequency waves. To convert from high frequency waves to low frequency waves, we use one special device that is called as what element? Antenna. Antenna is a device which we use to convert from high frequency signals to the low frequency signals. Okay, right. So this is a complete analysis of our subject. In our electromagnetic theory, we are going to discuss. So what we are going to cover now, here is potential energy, kinetic energy you already studied, we don't discuss now. Whereas coming to our syllabus, what we are going to discuss our syllabus is, so here first, so we can say this as unit 1, and we are going to discuss about the electric field. So this call it as static electric fields. Unit 1 is static electric fields, and the second chapter, that is the static magnetic fields. In static electric field, we'll consider the charges are at rest, and static magnetic field will consider charges are moving with uniform velocity. And third chapter, we used to consider that charges are moving with non-uniform velocity. There we used to talk about the electromagnetic fields. This is the first chapter. This is the first unit. Next, so we can say this as a second unit. and second unit, and that is the electromagnetic waves. So we have seen the static electric field, magnetic field. After that, VI waves means will be discussed in the networks. The networks we to talk about voltage and current waves, VI waves. And here we'll talk about the EM waves, electromagnetic waves. Okay. Next. And next one, next unit, unit 3. So this is transmission lines. Next one is transmission lines. And next we are going to discuss about this as a waveguides. And the next one will talk about the antennas. This is the complete syllabus of the EMT. And coming to the electrical fellows, so electrical fellows gate के लिए only this is the topic for electrical gate. Gate के लिए only this is the first, only this topic is for electrical gate के लिए only this topic. Okay. Yes, now EC को remaining topics. And but for electrical, if they are preparing for ESC, so the second unit, third unit is also. For EC, all the chapters are the syllabus. When you are coming to the weightage for electrical, so this is electrical ka weightage, it will come it as a 4 to 6 marks. Electrical ka weightage, it will be 4 to 6 marks. And EC ka weightage, EC has a very good weightage. They will have a minimum of 10 to 15 marks they can have. 10 to 15 marks per gate के लिए. Okay, this is the weightage. This thing. I think with this thing, so all of you might have some clear idea about these things, what they want to do and all. Isn't it clear to everybody? So everybody has a brief idea about this thing now, isn't it? Now, so with this, you might have some idea about this thing here. Now, so here, and the student who want to join in this to have a great learning experience from the Unacademy team. So here is a great opportunity to all the aspirants. Now this Unacademy subscription that is just 8,999 only. Yes, we'll provide the complete EC electrical syllabus will complete correct. And so 8,999 only, you will get flat 60% of discount. And so the offer is extended up to 15th of June. Yes, you can use the code of BV Reddy and to avail these opportunities. Use the code of BV Reddy and to have a great learning experience. Now we are starting the new batches. We are starting, you can have a look at now here. For 2027 के, so here आज से नया बैच शुरू होने वाला. Yes, we are the digital and EMFT starting. So plus में, so here daily my class is at 11:30 a.m. So then you can use the code of BV Ready and to avail this opportunity. Right. So you can see this is for 2028 के लिए भी नया बैच शुरू किया हमने. तो सेम सब्जेक्ट्स आर रनिंग, यू कैन फाइंड द टॉप एडुकेटर्स टीम आपको एक साथ मिलेगा. These are the Unacademy Gate 2026 का rankers. You can have a look at now. These many rankers, these are only from EC and electrical only. And ESC 2025 का rankers, you can have a look at now. These are from all the branches. Right. And what we offer now, we do offer the two subscription. One is Plus, the other one is Iconic. Plus में top educators classes will take the both EC electrical का सारे के syllabus खत्म करेगा. Yes, I will do both EC and electrical का syllabus. I will do both part. I will do live doubts, evaluated test series, structured courses, PDF, live quiz, unlimited access. आइकॉनिक में एडिशनली आपको क्या मिलेगा? पर्सनल कोच भी मिलेगा, फिजिकल नोट्स भी आपको मिलेगा. Yeah, that's it for today's class. So you can start a serious preparation with the Unacademy to achieve your dream goals and start your serious preparation to have a great learning experience. Okay, that's it for today. And the next class onwards, as usual, in the plus में हमारा class continue होगा. नेक्स्ट क्लास ऑनवर्ड्स प्लस में हमारा क्लास कंटिन्यू होगा. आज के लिए जस्ट ओरिएंटेशन सेशन है. सो हियर नेक्स्ट क्लास विल बी कंटिन्यूड एज यूजुअल इन द प्लस में. ठीक है. होप विल मीट इन द नेक्स्ट क्लास इन प्लस में. हम विल मीट नाउ टुमारो ऑनवर्ड्स एज यूजुअल प्लस में हम कंटिन्यू करेंगे. ठीक है. So to join it now, use the code of BV Reddy and immediately तुरंत plus per hour will have a great learning experience. ठीक है. चलो, yeah, that's it for today. We'll meet tomorrow. Yes. See you. Bye bye. Let's crack it.